Okay, so in the last session, we had a discussion on how to insert a node at the end of a given linked list. Okay, and we have seen a function for it, and then we have also seen the presentation on it, that how the new node gets added at the end of a given list. So we are done with that, and this is the code for that. We have insert at end function, the function, this function which inserts a given data, this data, at the end of the given list, the list which is pointed by the pointer h. Okay, so here we have the pointer h. So this function is going to get two things: the head pointer of the list in which a new node is to be inserted, and second one is the data which will be inserted into the list at the end. Then we had a discussion on this function, how it does the work. Now, the next thing, before the proceeding to any other important operation on a linked list, we need to see that basically how the content of the list is displayed. And that is important, so that after implementing every function, we can have a program handy with us, so that we can check whether the functions are working or not as per the expectations. So now we can work with the display function. So once our insert function is ready, display function is ready, then we can execute the code. We can check whether the insert operation is properly working or not with the help of display function. So after every insertion, we can check the content of the list with the help of display function. Likewise, once we implement the other version of the insert function, like insert at the beginning. So after implementing that function, again, we can check with the help of display function whether the function is doing its task or not, whether it is properly inserting the given node at the beginning or not. Okay, so this display function is important to check proper working of other functions. Okay, so we'll be doing this display function now, and let me call it display. And what we are expecting into the display function, what the display function should be reading. Obviously, the display function would be expecting a list which has to be displayed. Okay, so the display function is accepting a list, and list is what? Pointer to structure SLL. In this case, our structure name is SLL, singly linked list. So it is a pointer to structure SLL. Let me call it H. Since the display function is there only to display the content of the list, the display function is not at all expected to return anything, and so the return type becomes void. What we will be doing into the display function? The first thing we need to check is whether there is something or not into the list, into the given list. If there is nothing in the given list, then we need to display the list. Linked list is empty. Else, we need to display the content. So the first thing we need to do is check for the empty condition of a given list. The given list pointer is getting into H, pointer H, and if this H is null, so it means that the list is empty. So we'll be checking for this. We shall be displaying here the entire. I can say linked list is empty. Fine. Let me have it on new line. Okay. Else, in the else part, we will be doing our code. Which code? We need to display the content of a list. We know that there is something into the list, and we need to display the data of all those nodes which are present in the list. Okay. How we'll be doing that? A simple thing is to traverse the list. What we need to do? Traverse the list. Start from the first node, display the data of the first node, go to the next node, display the data of the next node, go to the next node, display the data of the next node, and so on till you reach the last node. When you reach the last node, displays content, displays data. Then after that you will be going to null, because the next pointer of the last node will be always pointing to null. So the moment you reach null, you need to stop. Okay. So the moment your pointer reaches null, you need to stop. So here I need a temporary pointer, and as I said you in the last session, you in C and C++ you can declare the variables immediately after the start of block. So here I can declare a variable that is a pointer to struct SLL type. Let me go with a temporary pointer TMP. I shall be initializing it to the first. It should be pointing to the first node initially, and the first node is pointed by h. In this function, I would be saying TMP equals to h. The moment I say TMP equals to h, the temporary pointer TMP starts pointing to the first node. Okay. Now, when this is the case, now what we need to do, we need to check why. In the last session, when we were implementing the insert at end function, so here this was the condition. While TMP of next not equals to null. Okay. Now, this was the condition because we wanted to go till the last node. And the moment we reach the last node, we need to come out of a loop. I repeat, the moment we reached the last node, we were supposed to come out of the loop. Okay. Here in this case, in a display function, when we reach the last node, that time we need not have to come out. We need to process the last node, and then we need to come out of the loop. Okay. So here in this case, the condition should not be temp of next not equals to null. Rather, the condition should be simply temp not equals to null. Hear carefully. Temp not equals to null. Inside this, since the temp is pointing to a current node, for the first time when the loop executes for the first time, it shall be pointing to the first node. So since it is pointing to the first node, I need to display the data of that. So I would be saying printf, and suppose on new line with a tab space, there are two tab spaces, I am displaying the data. My data is of integer type, so %d, and here I need to say temp of data. This will display my data, and then I need to proceed with the next node. So I would be writing temp equals to temp of next. Temp equals to temp of next. Okay. To improve the presentation before the while loop, here I would be saying st English content. Okay. Then in the while loop, while temp not equals to null, then temp of data temp equals to temp of next. That's all done. Anything else? Anything else required here? Please. If we are missing anything, then let me know into the chat box. or according to you also we are done. We have completed the function. We wanted to display the content of the linked list, and we are doing that. So is this enough? Or anything else is also required? Yes. There is no reply from any of the students. This function is the simplest function. This is the simplest operation that you can perform on an linked list. So it should be clear and straightforward. It should be clear and straightforward. Semicolon. Okay. So now we have a end function ready with us. We have a display function ready with us. So what we'll be doing, we'll be making our main function also ready, and there we'll make the required changes. Am I audible? Okay, my screen getting changed because I'm making changes over here. I'm changing the main function, but whether those changes are visible there? Yes. For me, those changes are not visible. Yes, sir. Okay, yes, yes, it's coming. So what we need to have, we need to have here an infinite loop, just like our other program. And inside this infinite loop, we'll be doing our entire task. So I don't want to repeat that code. It will be taking a lot of time. So let me get that main function part from, yes, from this function. So what I do, I simply copy this entire code. This is simply the main function, and you all also know how to write a menu-driven code inside the main. So let's not get into that because that will take extra time. So you know how to make up a menu, how to give the options. So all those options are here. And what we have right now, we have insert at n function with us, and we do not have case 2. So I will comment it out. And I do not have case 3 also. Comment it out. And case 4 also not there. right now. Comment it out. Then case 5 is there to display. Fine, absolutely fine. So, case 1, see here carefully what we are doing. We are asking for the data from the user, and then we are scanning that data into a variable D, and then we are calling our function insert at end. And see what we are doing. We have to send two things, two parameters or two arguments. The first argument is the head pointer of the list in which we need to insert the data, and second is the data itself. So the first pointer is the head pointer of the list in which we need to insert the data, and second is the data itself, that is D. Okay, so that's what we are doing. This is our head pointer, and we are initializing the head pointer to null. This is important, this we need to do. And then we are sending this head pointer to the insert at end function, and this function insert at end, it will be working on the given head pointer, and it will add the given data into the given list, and then it is returning a pointer. So that pointer also you need to take into the head, and that's why our statement becomes head equals to insert at end in parentheses head comma D. This is important. The pointer value which is returned by insert at end, that we need to take back into the same head pointer. Then only our list would get updated. So we are writing head equals to insert at end head comma D. Okay, and okay, that's fine, absolutely fine. So let's save this code. Let's compile it. This session 19.c. Some warnings and notes. There also head equals to null. Should not be there. Issues. Okay, done. And I will be going into my folder. Oh, you are not able to see that. Huh? Let me stop your presentation. I can share my entire screen. So then you will be able to see my code execution. Okay, so we have compiled our code, and the code is now a.exe. Let me execute this code. I need to and missed including the important header file. Yesterday. Okay, so our code got compiled. Now we have session 19.exe with us here. Double click on it, and now what we can see a menu. And if I go for the fifth option, which is a display, so I get an output that the linked list is empty because our list is empty right now. We haven't inserted anything. So let me go for the first option, the insert function. And this is by default insert at end. So when I execute this, so it asks me for the data, enter data, and now suppose I'm entering 10. Then insertion has been done because, but there is no message. Okay, so we can check for that also. Meanwhile, insertion has been done, and let me confirm this with the help of display function. If the display function displays the content of the list and it displays that there is a node 10, so we can say, yes, it has been done. So let me check. Okay, so linked list content, and we are getting the value 10. It means that 10 got inserted. Let us insert one more, and sorry, first choice, and I insert 20. And now let me go for the fifth option, display. And yes, it is getting displayed. So our data structure, linked data structure is getting grown up dynamically. It is growing dynamically. Okay. First it was empty, then we inserted 10, then we inserted 20, and so on. And when I say that it is growing dynamically, so let's make that also as a part of the display function. So let us try to display the size of the list in the display function itself. So the moment it keeps growing, the moment we are adding the nodes, the size of the data structure should increase. Okay. So let me stop this code and let's go to our display function into this. So what we'll be doing over here, mm, we know that the size of one node is size of struct SLL. So if I display size of struct SLL, so I will be getting the size of one node in terms of bytes. Okay, and if I multiply that number with the total number of nodes, so in that case we'll get the size of the linked list. I repeat, size of one node into number of nodes will give us the size of the linked list. Okay, so let's do that. And for that, let us declare one variable, say n, to find the number of nodes. So n equals to 0. And here inside this while loop, since this while loop is going for each and every node, and it is going to the last node. So in this while loop itself, we can count the number of nodes simply by writing n plus plus. Okay. So I'm incrementing the value of n by 1 inside the while loop. So for every iteration of the while loop, n will be incremented by 1. Okay. So it is going to every node. So the moment it reaches to the next node, the value of n will be incremented by 1. So finally, it will give you the count of all the nodes in the given linked list. So now, after this, I can print f on a new line with the backspace. I can say size of English is, or like this, percentage the bytes. Okay. Here I will be saying n, that is the total number of nodes, into n into size of operator, size of what? Size of structure SLL. Okay, done. So now this should give us the size of the entire linked list. Okay, n into size of struct SLL. Anything we need to do? Fine, that's done. So let me save this code. Let's recompile this code. It's saying code is already running. Let me restart my Visual Studio Code. So session 19.c, it got compiled, and this 19.c exe file should have been overwritten. So let's execute this. And if I display, this is an empty list, so linked list is empty. And then we go for some insertion. So let me insert say 10, and 10 has been inserted. Let us display now the fifth option. Okay, so if you see carefully, so the linked list content, and you have a content of the linked list. Only one element is there, 10, and the size of the linked list is 16 bytes. Okay, so it is quite possible that on this platform on which I am running my code, on this platform, integer is taking 8 bytes, and pointer may be taking 8 bytes. Okay, so 8 plus 8, that is 16, because we have only one node into this list, and that is a possibility, 8 plus 8, or it can be 4 plus 12 also. I do not know, I need to check it separately, and that is also quite straightforward. Size of int, if you write printf size of int, it will give you the size of int, and if you write printf uh, printf percentage d comma size of int, so it will give you size of int. If you write printf percentage d comma size of uh, in bracket struct SLL star, so it will give you the size of a pointer to structure SLL. Okay, so let me add one more now. Let's try to see whether it is growing dynamically or not. So I have inserted one node, that is 20, and now let's display the list. And yes, linked list content 10 and 20, and the size of linked list is now 32 bytes. So earlier it was 16 bytes only with one node, and now with two nodes it has got 32 bytes. Okay, and likewise, if we keep on inserting the nodes, you'll keep on getting the increased size. I go for the fifth one. So now we got three nodes, 10, 20, 30, and the size of our linked list now is 48 bytes. Okay, so for every node, it is getting increased by 16, because the size of a node, one node is 16 bytes. Okay, any query into this? If you have any query, then please let me know. Your chat box is visible to me, else we can proceed. And it is good that whenever you display the list, you should also display the size of the list. So every time you come to know how the linked list is growing and how it is shrinking. Because now we haven't implemented the remove function or the delete function. So when we implement the delete function, so after insertion, we can display the list, we can check the size, then we can go for deletion. Then again, we can display the list, then we can check the size. So for every insertion, the size should be increasing. And likewise, for every remove of, for every deletion, the size should be decreasing. So that we need to see. And that we can easily see with the help of search a display function, which is also displaying the size of a list. And internally, what we can see here that we are also counting the number of nodes. So in this display function, with the help of this simple variable n, we are counting the number of nodes. Okay. So for that, we do not have a separate loop inside this loop only, because this loop is perfect to count the number of nodes. So inside this loop only, we are implementing our counter, and then finally we are finding the number of nodes in the list. In fact, this could be one of the operations on a list, that you need to find the total number of nodes present in the list. So it's not a big task. It is exactly similar to your display function. Only the return type becomes can become int because you are returning the size of the list, and there you can check that if the list is empty, if the list is empty here, so here you can return zero, that there are zero nodes, or else you can have this code. You need not have to display anything over here, and you only need to count. Okay, so temp equals to temp, the same loop, no printf function, temp equals to temp of next, then n plus plus, and finally after this while loop over here, instead of this printf, you can simply write return n. Okay, so that will return the number of nodes. So this way you can have one more function which can count the number of nodes in the given linked list. Okay, so this is how you can perform different operations on a list. Any query? No query, so it is understood by all. Can I assume that it is understood by all? Yes. Okay. Understood it. You have seen this code for inserting a node at the end. What if I need to modify this code? So then I have function to insert at the beginning. So this code is to, or this function is to insert the given node or the given data into the given linked list at the end. And what if I need to do the same task but at the beginning? At the beginning means my head pointer should be changing. The new node should become the first node. Here in this case, the new node is becoming the last node, but in the next variant or the next version of the insert function, which is insert at beginning, the new node should become the first node. So how that can be done? Any idea? Yes. What I do, that function is quite simple and straightforward. So for you people, I copy this function and will be changing this function itself. Okay. So I have one more copy of the insert at end, and now I will be making it insert at back. So insert at beginning. So this becomes insert at beginning. Same prototype, and then we'll be creating a new node. Yes, we'll be checking for whether the node has been created or not. So this is also true, and this is also fine. This is also absolutely fine, and this node can be a first node. So this is also absolutely fine. Then in the else part over here, we need not have to traverse because when we wanted to add the node at the end, so that time only we wanted to go to the last node. Now this is insert at the beginning, so you need not have to traverse. Okay, so we won't be having this code. This is not required. So what we need here, we need to make the new node as a first node. Okay, so my new node is this P. So what I would be saying that P of next equals to P of next was null. Now I want P of next to point to the first node. I repeat, P of next should point to the first node, and first node is pointed by H. First node is pointed by H. So I would be saying P of next equals to wedge. So now P of next is pointing to wedge. So P of next is pointing to the first node. And then I need to make this P as the first node. This P as the first node. So I would be writing H equals to P. Okay. So now we have made this as the first node. So yes, this is done. We need not have to do anything extra. In fact, we can compact this code also, but this is the simplest way of doing it. And we are ready with one more function insert at beginning. And let me call this option as insert beginning. Insert begin. And this is the second option. So I need to remove this commenting. I will be asking for the data, and then I am calling insert at beginning, and I am passing two things, head and b. Done. Okay, so this is done. So let's try this code. Let me compile it. Saying code already executing. Let me stop this. Let me stop this. Let me start my Visual Studio Code. Let's compile our program. Compiled, and now let's execute this. Okay, so the first option is insert, the second option is insert beginning. So let's have few insertion. I inserted 10, and then I am going for the first option again, insert at end. So I'm inserting 20. So the first node is 10, second node is 20, and let me display. So yes, we can see first node is 10, second node is 20. And then I go for the second option, insert at beginning. And now I'm inserting say 30. So now 30 should become the first node as per our logic. So let's see whether this is happening or not. Okay, it got inserted. Now let's display it. So when you display it, so you can see that the 30 is the first node, 10 is the second node, and 20 is the third node. And then the size of our list is 48 bytes. Now I go for one more insertion, but insertion at end, and I insert say 40. Let's display the list. So there are four nodes, 30, 10, 20, 40. Let me insert at beginning, second option, and I insert 50. So my 50 should become the first node now, and let me display it. So yes, the 50 is the first node now, 30 is the second node, then you have 10, then you have 20, then you have 40, and finally the size of the list is 80 bytes because there are 5 nodes into our list. Okay, so this is how we have easily and quite effectively converted the same function insert at end to insert at beginning, and that's what I was saying you that once you understand the basic things, then it's become quite easy to work with the linked list. But if you do not understand the basic things, then it is damn difficult to work with the linked list because it's all about pointers. It's all about pointers. We play with the pointers. So if you are good with playing with the pointers, then you can do a lot of things quite easily. And this code can also be, you know, this code can quite easily be reduced because there are few things which is not required over here in this code also, and this entire stuff, this entire stuff I think all these statements can be reduced to two statements. So 1, 2, 3, 4, 5, 6, 7, 8, 9 lines can be converted only into two lines, two statements. That's all. And it will be doing the same task. So it's I leave that up to you. You can compact this code, and I repeat the lines which I have highlighted. All these lines can be converted only into two lines, and it will be doing the same task. Okay, insert at beginning. Fine. So we stop now. Sheikh Zikra, you are getting the recording in your Google Drive. So